Are you ready to tackle one of the most beautiful yet challenging structures in modern architecture, the Ribbon Chapel? You've seen the elegant spiraling ramps and the seamlessly curved glass walls, but how do you actually model that complexity in Revit? It's not just about drawing a floor. It's about mastering sloping elements, dealing with complex geometry challenges, and ensuring your glass walls attach perfectly to a ramp's curved bottom. In this Zero to Hero masterclass, I'm Farzaneh, and I'm going to show you the precise steps, tool by tool, to overcome every obstacle, from the auxiliary levels to the perfect custom balusters. Ready to turn this architectural dream into a precise 3D reality? Let's dive in. First, we drag the site plan into Revit. The first step is to set up the units. I will press the UN key on the keyboard and set the unit to meters with 2 decimal places. I select the map plan, click on Scale, and now click on the start and end of this specific section. I type the number 1 because the plan indicates the segment is equal to 1 meter. Now on level 1, I click on Floor and begin to draw the pink boundary line. I can draw the other side of the ramp using the offset tool. In reality, this path is a staircase, but my intention is to teach you how to draw a sloped surface, ramp, and how to set its slope. Now, I have to draw some sections manually because the ramp's width changes. I will also draw the start and end sections of the ramp to create a closed shape boundary. I now drag this section view into the elevation screen and adjust its scale. I position it to align with level 1. I downloaded these images from various sources, so the scale of the site plan and the section view is slightly different. To unify them, I click on the image. I select the scale tool and click on the starting point of the imaginary line I want to change. Then I click on the endpoint of that imaginary line. The third click is the endpoint of the imaginary line that I want the first line to match in size. I derived this measurement from the 2 endpoints of the floor I sketched in the plan view. We have 2 ramps here. For the first ramp, we must draw a series of auxiliary levels to precisely and easily determine its slope. Now I press the LL key twice on the keyboard, or I select Level from the Architecture tab. I want the levels I draw to only show up in the elevation view and not create an accompanying plan view for them. So I uncheck the Make Plan View box. I will now create levels at the points where the ramp is cut by the section line. If you need more explanation about levels, I have prepared a dedicated tutorial for that called Revit Levels, Master Elevations and Custom Level Symbols, Zero to Hero series. I will include the link for you in the description. I select the ramp and click on Modify Sub-Elements, then I select this line. The value I input for it is the number indicated by level 7. As you can see, it moved up. Now, I will gradually decrease the values until I reach 10, which is the next section. I'm estimating here. It would be better if our line were exactly in the middle, but I don't want too many breakpoints, so just input 10 for now. The reason they don't align perfectly is that our plan and section are not entirely matched. I can use Add Split Line to draw a line wherever I need to create an elevation level. The section line is approximately here. So I will consider an elevation of 10 for this line. For this area, I will set the height between 10 and 12.5. Since we don't have precise plans and we didn't design it ourselves, defining a ramp becomes a little difficult. But that's okay. After accurately modeling this building, you'll become a master at ramp modeling. I can select these points separately and adjust their height. I can also create new points from the top, using the modeling tools. Now I will adjust the ramp's height to match the levels I created. I will keep changing the values until the ramps align perfectly with each other in the section view. Now I select 4 again from the Architecture tab and draw the next ramp based on the plan. In this area, the ramps interfere with each other, so I'm forced to draw them in separate segments. I delete the unnecessary parts. Now I draw a split line for the sections that I need and that are aligned with the section view. I check the result in the 3D view and easily adjust the elevations in the plan view, while simultaneously checking the section view to make sure they align perfectly. Here, one point has risen, so I will convert it to a line so that it rises uniformly. I can select the points individually. Now that the height of the main lines is defined, I adjust the rest of the lines to create a uniform slope. Now I will draw the next part. Since this is repetitive, I will speed up this part. It gave a warning that the floors overlap, but that's okay. Once the slope is correct, it will align with the previous floor. How do I know which value to enter for the slope lines? I use the auxiliary levels. I set the elevation for the section line locations first, and then I adjust the area between them with values that create a uniform slope. section, we fully practiced using the Modify Sub-Elements tool. The main part of the structure was precisely these spiraling slope surfaces. The rest of the work will be much easier. Okay, let's remember to save the file. I also have a ground floor plan that I want to use for drawing the walls. I drag the plan into level 1. I correct its scale using this linear scale line. I adjust its placement. It might not align perfectly with the model because we drew the slopes using a site plan with a slightly different scale. Even though we corrected the scale, some non-alignment is natural. I set the view style to wireframe so I can see under the model. In this plan, the starting piece of the ramp is different, so I will correct it as well. I double-click the ramp to enter the edit mode and draw the new boundary lines. Since this is a repetitive process, I will speed up the video so the tutorial doesn't get too long. I also adjust the slope of the ramp segment. I edit this connection point so that it aligns with the initial ramp. Note that every segment that is edited will have its slope reset to 0, so we have to adjust the slope again from the beginning. Now I can delete the auxiliary levels that I had created. I don't need them anymore. I select the floor tool and model the main floor of the chapel. It gives an error indicating that it is interfering, overlapping with the ramp. I use the paint tool to apply material to both the ramp and the floor. By activating the section box in the 3D view, I can gain easier access to the specific area that I intend to model. I I model the surrounding glass walls using the curtain wall tool. I select the walls and click on Attach Top Base. Some of the walls do not attach to the ramp because they're not fully underneath it. I adjust their position slightly so that they are completely located beneath the ramp. Then I select them one by one, click on Attach Top Base, and then click on the ramp that the wall should attach to. I select the walls, copy them from the top here, and then from this section I select Align to Selected Levels and click on Level 2, so they're copied onto Level 2. I select the copied walls and the ramps and isolate them from here. I select these walls and set the base constraint to level 1 so that I can use Attach Top Base for the upper part. The reason why one part of the wall didn't attach to the top is that it was not completely under the ramp. I apply a 5 cm offset from the ramp's edge to make it larger so the wall is completely beneath it. For the same reason, I will also enlarge the rest of the ramps so they are continuous. For the lower section, I double-click the wall to enter the edit mode and manually edit the bottom boundary of the wall. To continue, I will create a level with an accompanying plan view and place it at the elevation where I intend to draw the continuation of the glass walls. This piece of the wall did not attach to the top, so I will slightly increase the ramp's width so that the ramp is above this section as well, allowing it to be attached. If a section doesn't attach, we can draw its dimensions manually. To draw the railings, an easy way is to use massing. From the Massing Insight tab, I click on In Place Mass and open a new mass. Now, using the spline tool, I click along the edge of the ramp. We must be careful to click exactly on the edges, it snaps very easily. Now in the front elevation view, I make a copy of it. I select both curves and click on Create Form. Undo. I move the upper curve slightly. Perfect. I repeat the same process for the other edge. It looks very beautiful. You can isolate the ramp. This makes drawing the mass easier and you won't struggle with clicking like I did. Now for the railings, I select a wall and go into its Edit Type settings. I create a duplicate of it. I choose the material for it and set its width to 5 centimeters. A thickness of 1 centimeter is good for the finishes on both sides. If you are not familiar with wall layering or would like to see a complete tutorial on this topic, I have prepared one called Revit Walls, Master Layers, Details, and Custom Caps, Zero to Hero series. I will put the link for you in the description. If I click on this icon and then click on the mass volume, it assigns the wall to them. Now from the Masking and Site tab, I click on Show Mask to turn it off. And now we can see the railings. There is another way to draw the railings. You can either watch that method or proceed to the next section of the tutorial. I will draw another ramp over the previous one, this time using fewer clicks. This reduces the number of breakpoints and the points I have to modify for the slope, resulting in a smoother ramp. Now, I click on Railing from the Architecture tab and use this tool to click along the edges where I want to place the railings. We create the railing that easily. I select the railing and go into Edit Type. I click on Baluster Placement. I input different values for the distance parameter so you can see the difference. Now I will create a new baluster. From the File tab, I click New, then Family. In the English metric folder, I select Baluster Panel. I could also select Baluster Post. I enter the front elevation view. In the Create tab, I click on Extrusion. It asks me to define a work plane. I select Pick a Plane, click on this line and choose the left view. I sketch the desired boundary. We must draw on the lines. Now I select a line, click on the reference line, then on the line I just drew and finally click on the lock icon. This way, if we make any changes to the parameters later, the panel size will also update. I repeat this for all 4 sides. And I will set the extrusion amount to 10 centimeters. There's one thing I should have done at the very beginning. I pressed the UN key on the keyboard and set the unit to meters with 2 decimal places. If I change the width parameter from this section, my sketch will change by the same amount, because I locked it. I will set the width to 10 centimeters and the height to 1.5 meters. Then I click on Load into Project to import it into the main project. Now I go into Edit Type. I set the spacing distance to 10 centimeters. And I assign the family we just created together to all the balusters. I set these other distances to 0. I also assign a material to it. I enter the family environment, select it, and create a material for it from this section. I click on Load into Project again, and then click Overwrite. I set the visual style to Realistic so that it displays the materials. I mistakenly set the thickness to 1 centimeter, so I will change it to 10 centimeters. And I click on Load into Project again. This handrail must also be wider. To easily distinguish the ramps, I will create a new material from the Manage tab. And now I use the Paint tool to apply it to the ramp. Another way is through the ramp's own Edit Type settings, which I taught in the floor layering video. I will include the link for you in the description. Here, I change the color from pink to blue. I activate the section box. Here, I want these glass panels to sit exactly on top of the 10 centimeter edge of the railing. I select them and move them using the arrow keys. I adjust the bottom boundary for the walls that I drew recently. I also check the rest of the walls and make corrections if necessary. Since this is repetitive, I will speed up the video so the tutorial doesn't get too long. I check to ensure that the glass walls start right from the 10 centimeter edge of the railing. I isolate the ramp. I draw the railing for it using the Pick Lines tool. We must ensure we select the same railing type from this section that we used for the other ramp, so we don't need new settings. Okay, now I reset the temporary isolate. I also draw the railing for the inner edge of the other ramp. Since the railing is currently resting on the ground, I select it and click on Pick New Host. This section ran into an issue because of this small up and down movement in the ramp. I will draw a separate railing for this specific section. The method using massing was both faster and resulted in a very clean and continuous railing. However, my intention was to teach both methods, so you can choose the best approach depending on the situation in different projects. I drew the railings in separate segments again to fix the parts where the floor had issues due to being segmented. Also, this ensures the railing sits correctly on the intersection of the ramp and doesn't protrude. If I press the space key on the keyboard, the wall's direction changes. I perform the final edits using the section box and also draw the upper glass wall. I use the floor command to build this upper section as well. To finalize the walls, I isolate these two sections. I then use the wall command with the pick lines tool to draw the wall. To adjust the wall's location, I create a level in the north elevation view and set the wall's base constraint to that level. Now, whatever height that level is at, the bottom of the wall will move to the same height. I easily align the top of the wall with the capping. I create a generic model in place family. I draw a reference line and set the work plane onto it. I use the Tab key on the keyboard to help select the vertical work plane. Now I draw a void extrusion and cut away the unnecessary lower part of the wall. I will perform this process again so you can learn it. Click on Cut, I select the void, and then click on the unnecessary part of the wall. To make the drawings more precise, I use several reference planes. Reference planes are very useful for creating work planes. I will also finalize the last wall. Now, I create a new generic model in Place Family. I draw a circle to model the metal rods. I specify its height and assign a material to it. Next, I draw a large circle so I can use its center point for the copy rotate command. I select the metal rods and click on Rotate. I ensure the copy option is checked. I click on Place so I can define the center of rotation. I click on the center of the large circle and then rotate it by the desired amount. When the mouse gets close to the circle center, Revit indicates it with a faint purple circle. I copy the metal rods to all the corners. I click on this check mark, Finish Model, to exit the in-place generic model environment. Now I extend the metal rods upwards by dragging this arrow. If any editing is needed, I double-click the metal rod or click on Edit in Place. To change the radius of the metal rods, I click on them to enter the edit mode, click on the radius parameter, and input the new value. I repeat the same process for the upper ramp. to apply materials better, it's advisable to model each of these pieces separately so the material can be rotated easily on them. Wherever the material meets rotation, I will model it separately. Now, for the top rail of the railings, I click on New from the File tab, then Family. I select the English folder, and then choose Metric Profile. We always start by setting the units by pressing the UN key on the keyboard. Here, we draw the top rail profile section and then click on Load into Project. I select the railing. In Edit Type, under the top rail section, I click on Type and choose the family we created from the Profile dropdown. Now I need to change the handrail clearance value so it sits exactly on the railing. It's corrected with -20 centimeters. And there you have it, the complete complex model of the ribbon chapel, finalized and ready for the next stage. We tackled the spiraling ramps, mastered the Modify Sub-Elements tool, and there you have it, the complete complex model of the ribbon chapel, finalized and ready for the next stage. We tackled the spiraling ramps, mastered the Modify Sub-Elements tool, and created custom balusters from scratch. But the journey isn't over. What happens next? Now that the model is perfect, you need to see it in a photorealistic environment. Click here for the next video, where we take this exact model and turn it into a stunning cinematic render in Unreal Engine 5. And once you've seen the render, get ready for a complete design challenge, the full modeling and rendering tutorial for a spectacular mountain villa. Don't miss a single step of the ArchViz Ascent. Subscribe now and join us for the next tutorial.